Hello students, welcome back to maths class. We are dealing with the differential equations. So in previous classes we completed the degree of the differential equation, order of the differential equation. After that we have to form the differential equation. Another form of equation will be given. That means in equation some constants will be there, right? So we have to eliminate the constant terms from that differential equation, right? So those are over. Now we have to solve the differential equations. So different methods are there to solve these differential equations. Okay, so first method is called variable separable method. Variable separable means x terms are one type of variable, y terms are another type of variables. So we have to separate all the x terms into dx and all the y terms into dy, right? So then variables will be separated. Once we separate the variables, just take the integral for that, right? And solve the problem. That is called variable separable. In the name only it is there. We have to separate the variables. All the x terms into dx, all the y terms into dy. Once separated, just take the integral for that. So come on, I will show you how we have to separate. So take the first question. So which method we are doing? Variable separable method. Just we have to separate the variables, all the x variables, all the y variables. All the x variables into dx we have to take. Y means we can integrate with respect to x. All the y variables into dy we can integrate with respect to y. So come on, what is the given differential equation? Given differential equation is, what is that? It is dy by dx is equal to e to the power of x minus y plus x square e to the power of minus y. So how we can separate the variables? X terms one side, y terms one side. So dy by dx is equal to, this can be written as e to the power of x by e to the power of y. You know it, a to the power of m minus n can be taken as a to the power of m by a to the power of n. Okay, so similarly we can write this as x square by e to the power of y. So what is the LCM? LCM is e to the power of y, e to the power of x plus x square. Now observe, these are the x terms, this is the y term. Here we are having dy by dx. So send y term along with the dy and send dx to x terms. So what happens? It is e to the power of y dy is equal to e to the power of x plus x square into dx. Okay, so now integrating on both sides. Once the variables are separated, just take the integral and solve it. That is called the variable separable method. Just we have to separate the variables, x variables into dx, y variables into dy. After that, taking the integral. That is called variable separable method. So you know it. What is this? Integral e to the power of x dx is e to the power of x. So it is e to the power of y. With respect to y, we have to integrate. And here, whenever plus is there in integrals, we will take separate integrals. So it is integral e to the power of x dx plus integral x square dx. So e to the power of y is equal to integral e to the power of x is standard formula, e to the power of x, and this is x to the power of n form. Integral x to the power of n is x to the power of n plus 1 by n plus 1, 2 plus 1, 3 by 3 plus c is the answer. After completing the integral, we will write plus c, right? These are normal integrals, not a definite integrals. Okay, so now come to the second question. So what is the procedure of variable separable? But they don't mention in final examination. solve this by variable separable. You should know we can easily separate the x terms and y terms together. Then we can separate x terms into dx, y terms into dy. Then we have to apply the integrals, right? They don't mention any method, homogeneous method, right? Variable separable method. Just they will give one differential equation and solve this equation they will give. So you have to recognize which type of method we have to choose, right? So if very easily we can separate the x terms one side, one term, y terms one side, you can go for variable separable method. With practice you will know all these things. That's why I am saying practice the problems on the day itself. Okay, so now come to the next question. What is that? Given differential equation is. What is given differential equation to you? It is x y square plus x into dx, right, plus y x square plus y into dy is equal to 0. Okay, observe carefully. In this equation we can take, in this term we can take x common, isn't it? Take x common, then y square plus 1 into dx, plus from this term y can be taken outside, x square plus 1 into dy is equal to 0. But all are there, x term is there, y term is there. See, x into y square plus 1, but dx is there, right? Y term and into x square plus 1. So we have to separate the variables. For that, divide both sides with, how we will divide? On both sides with which value? 1 plus x square, 1 plus y square, or y square plus 1 and x square plus 1, right? Then what happens? X into y square plus 1 into dx plus y into x square plus 1 into dy divided by y square plus 1 into x square plus 1 is equal to 0 by anything is 0 only, no need to write. Now write separately, x into y square plus 1 by y square plus 1 x square plus 1 into dx plus y into x square plus 1 by y square plus 1 into x square plus 1 into dy is equal to 0. X square plus 1, x square plus 1, y square plus 1, y square plus 1 cancels. Now your equation, observe how nicely you got it. We can write this as x by 1 plus x square dx, x terms into dx, right? Next, plus y by 1 plus y square into dy, y terms into dy is equal to 0. So now y into 1 plus y square dy is equal to, send x terms that side, x by 1 plus x square dx. So what I said, once we separate the variables x terms into dx, y terms into dy, you take the integral, right? So take the integral. Okay, so now how we can integrate? Already we finished one big topic, integrals, isn't it? So we have gone through all these type of problems. So we can go for substitution method, isn't it? T is equal to 1 plus y square. Then what happens to dt by dy? Differentiation is equal to 2y. Derivative of 1 is 0. Derivative of y square is 2y. We are having only y dy. So you bring this to this side. It is 1 by 2 dt is equal to y dy. See, y dy place we can take 1 by 2 dt. Similarly, here you take your s is equal to 1 plus x square. Right. Now you take ds by dx, right, is equal to, it is 2x. So here we are having only x dx, isn't it? But here 2x is there. So send that 2 this side 1 by 2 ds is equal to x dx. Okay, so now you substitute in the integrals. So implies it is integral, instead of y dy we can take 1 by 2 dt by t is equal to minus integral, instead of x dx we can take 1 by 2 ds by s. So 1 by 2 can be taken outside, right? So it is dt by t. Here also 1 by 2 taken outside, it is ds by s. Okay, so here we can cancel 1 by 2, 1 by 2. It is log t is equal to log s. I said while dealing the integrals, whenever at the end all values are in terms of log, we can take constant also in terms of log. So log c. Okay, so we can write this as log t plus log s is equal to log c. Log m plus log n is equal to log m into n. Okay, so this is log tc is equal to log c. Log cancel, so ts is equal to c. What is our t? We have taken t is equal to 1 plus y square. S is equal to 1 plus x square is equal to c is the answer. So just by seeing that you should know which method we have to go for. So can we separate the x terms and y terms together, right? If a possibility is there, that means can we separate the variables, then you can go for variable separable method. Okay, so now come to the third one. Actually that question is given for 2 marks, right? What is that? Solve this equation. It is very simple equation. What is given equation is, it is root of 1 minus x square into dy, right, plus root of 1 minus y square into dx is equal to 0. So actually see, x terms are there dy, y terms are there into dx is there. So how we can solve this problem? So send one term that other side. So 1 minus x square dy is equal to minus of root of 1 minus y square dx. Okay, now bring this value. See, y terms dx, x terms dy. Compulsory condition is y terms into dy, x terms into dx. That means this term should come here, this term should go here. We can send, it is multiplying. If you send that side, it will divide. Same thing, it is multiplying with the dx. Send this side, it will divides. So it is 1 by root of 1 minus y square dy is equal to minus 1 by root of 1 minus x square dx. Okay, once variables are separated, you know it, we have to take the integral, right? So you know this formula. This is your sine inverse y, this is your sine inverse x. After the completion of integral, we have to write plus c, right? So bring this value this side. It is sine inverse x plus sine inverse y is equal to c is the answer of this question. Okay, so variable separable problems means we have to separate the x variables, all the x terms into dx, right, all the y terms into dy. Once variables are separated, just apply the integral, right, you will get your answer. Okay, so actually first we got the definition of the differential equation. After that, degree and order, finding degree and order of the differential equation. After that, they will give one equation, we have to convert that equation into differential equation, right. Now today we have taken how to solve the differential equations. First method, variable separable method. If equation is given to you, just separate the x terms together into dx, y terms together into dy. That means we are separating the variables, x variables, y variables separately. X variables into dx, y variables into dy. Once they are separated, just take the integral, right? Then you will get your answer. Okay, that is called the variable separable method. So we solved 3 problems, right? So these 2 are 4 marks question. The third one is 2 marks question. Very simple. See, once again we are using all the differentiation as well as integral problems. That's why in the beginning of integrals only I said once you go through the formulas of differential equations. Okay, so in integrals, in definite integrals, in differential equations, these are nothing but the topics of calculus. We are using differentiation formulas as well as integral formulas. So be perfect with the formulas, then you can score out of marks from the calculus. Okay, so that's all for today. Have a nice day.